I study communities of bacteria called biofilms. Traditionally, when we picture bacteria, we think of them as individual cells living alone. But actually, if we look either in nature or in disease, we see that bacteria live and work together.
Bacterial biofilm is a very important lifestyle of bacteria cells. So when they form biofilm, they are very resistant to exterior threats. For example, they could be 1,000 times more resistant to antibiotics compared to the cells that don't form biofilms.
There are connections on multiple levels between biofilms and cancer. The organism that I study, Pseudomonas aeruginosa, is an opportunistic pathogen. What that means is that it's particularly good at infecting people who already have disease. So this is an infection that we see very commonly in people who have compromised immune systems as a consequence of medical treatment, and this includes a lot of cancer patients. So these infections are real concerns for people with cancer.
Infections involving biofilm, especially in our GI tract, our gastrointestinal tract, are found to be correlated with cancer development. And also cancer patients, when they become immunocompromised after therapy, they also develop all kinds of infections involving biofilm and all kinds of complications.
It causes these diseases that are very difficult to treat. But we still don't understand even the basics of how bacteria communicate and work together to accomplish everything that they do inside these communities, and that's what I'm trying to understand.
If we could understand biofilm better, we have a better chance to target different pathways or different mechanisms. So we have a better chance to develop therapeutic strategies to treat biofilm-involved infections.
One of the things that Damon Runyon support has allowed me to do is develop an imaging method to really look inside biofilms at high resolution. We see a ton of really interesting phenomenology that's totally unexplored. And I think recent discoveries from bacteria, for example, the CRISPR system, tell us that when we see microbes doing something new and surprising, we should really stop and take a look to try to understand what they're doing and why.
I feel like for scientific research, when you want to make breakthroughs, you really need to think outside of the box. And you need to have long-term funding to support this direction of research over and over years and years.
Science is hard. Science is really hard. I think every career stage brings its own challenges, but I think moments of transition and moments to take a leap are moments that are particularly hard. This is a step out into open space, and this is a time where it's really important to feel like you have a net of support under you so that you can really try to do something transformative.